ICF, insulated concrete forms. The genesis of that particular product is below grade foundation walls. And of course, it works quite well for below grade walls, and you waterproof it and you come up above grade. And when more recent times, the market share, they've gone into creating new markets for themselves, and they want to go above grade and create walls that are above grade. And that has to incorporate now a whole host of things that you didn't incorporate in below grade walls. There's no windows below grade, there's no doors, there's no fireplace penetrations, things like that. So once you go above grade, you need to think about interface details and how you're going to interface with other assemblies that are going to be on the above grade portion of your walls. ICF is more of traditionally a mass concrete wall, so you have a very strong and robust core of solid concrete surrounded on both sides by a layer of foam, which is amazing for thermal insulation. However, it doesn't marry easily into these other rain screen systems, which have these definitive lines of defense that are all lined up and stacked in that order. And when you join those together, it's fairly simple in terms of figuring out what is what. With ICF being a massive wall and all being one solid assembly that's physically connected together without an airspace, it was important to try and figure out what's the most airtight element, what's the watertight element. We already know what thermally is the most thermally efficient element, but you need to know how that wall is going to perform in order to be able to tie it into other building envelope assemblies. What we can do with ICF now, above grade, is we can use it as the entire enclosure assembly. You can use it as your wall, as your below grade, as your slabs, as your suspended slabs. So you can actually build a whole building with it. But the testing itself is showing out that you can actually build interfaces with it, tying to core and tying to specialized bucks that actually perform just as well or better than any other method of doing it. There is attention needed to actually do it right, and testing needed to prove that it's going to work out. The way that we end up testing these is we use a test method for air and water leakage that simulates 1 in 10 year wind and rainstorm. So we put a great deal of pressure across the test sample, and then we spray it with a deluge of water that's sort of equivalent to that once in 10 year rainstorm. We apply that to the sample for about 25 minutes, and we look for leakage. So we look for any water that comes in, and we vary that pressure depending on the exposure we want to have. So if we vary, if we put 300 pascals of pressure in, that's very similar to your typical condo in Vancouver. And when we apply 700 pascals of pressure to that sample when it's being wetted, that's sort of equivalent to a high-rise in Vancouver. Many of these samples that we tested, we were getting that high-rise performance rating out of, even though we're testing them without cladding and without any sort of special exterior water shedding surface. We're just testing that moisture barrier, that interface with the window. Once the testing is over, right now we're in phase 2 of the testing. So what we've done is we've taken a bunch of traditional ways and we've modified them and tweaked them slightly and developed newer methods of interfacing ICF with other interfaces like windows and things. We've tested those, and they've turned out to be very, very high performance. So we can actually connect windows to ICF now in a way that's equal or better than most other ways of doing it to other claddings. Only thing is, at this point, we're at phase 2 of the testing. We're moving into phase 3, which will be real life testing. And we're going to take some buildings that are out there that are being built. We're going to try this, and we're going to make sure that in the field you can achieve the same results that we achieved in the lab. And if we can do that, which I don't see any reason why we can't, we'll develop a best practice guide for ICF, put together some details, help contractors in the field come up with different ways of doing it that they know are going to work.